Hello, good evening. It's Programmer's Life. Thank you for watching all the episodes in this language, and please don't forget to subscribe to my YouTube channel, Programmer's Life. Okay, back again. This is where we ended in the previous episode. We had started talking about control flow or program control by using what we call control statements, and I'm sure we ended with this example here that was using an if-else statement. So in the next bit I want us to use what we call sequences of an if statement. So I'm looking for a perfect window where we ended last time. I remember we even talked about this called duration. We talked about the if else, we talked about the if, the syntax, and how they all operate. So within the same line I want us to look at what we call sequences of, it's called if, else, if, else, if, then definitely it ends with an else. So as usual, let's try to zoom in a little bit. Now this is also another form of nesting, the if statement. So sometimes we need to use this sequence of structures where the else clause is the last bit of it, but again we can allow to have as many conditions as possible within the execution. So cases whereby you have quite a number of conditions to test, then in such situations it is allowed to use another if condition within a previous if condition. So what does this mean? This means that we can have a syntax which says if, so that is the main condition. So then we can say else if we can have another condition. I'm going to put it right later. Then I can again say else if. So here, like we've said, let me put it down here, we can have as many else if statements as possible, but we definitely end with else. So here this will be condition 1, this will be condition 2, and this will be condition 3. So code if condition 1 is true, the same thing applies here. Code if condition 2 is true. Okay, code if condition 3 is true. Then here we shall say code, sorry about that, code if all, code if all conditions fail. Okay, so this assumes that the last else body caters for cases whereby all conditions have failed to be satisfied. So how does it really work? How does it really work? It's very simple. All conditions are tested, but the condition that say that satisfies sorry about that, that satisfies the testing, then its code is executed. That is how it basically works. Okay, now assume we had an example. Assume we had a question, a program that accepts marks for a student in programming, then it what's a grade using the scale below. Okay, it's a program, it's gonna award a grade, but we shall be using the scale below. Greater or equal to 90, that is gonna be a plus, we assume. Greater or equal to 85, that is gonna be A. We are thinking in terms of a class. Greater or equal to 75, that is gonna be a B. Greater or equal to 65, let's call that a C. Greater or equal to 55, A, B, C, D. Then greater or equal to 45, that is E. Then definitely whoever cuts that line, then they have failed. So assume you had such. Then even previously, which tab was it? Was this the same tab? We had a question which requires us to almost use the same. A program that accepts a letter from the keyboard, then it tells if it's a vowel or a consonant. That can also work. Okay, definitely. So this can also work. So we can opt for using what we call the sequences of the if statement. So what we are going to do, let's pick this one very fast, and let's try to have a program. Okay, as usual. So let's make this one a multi-line comment to make life simple. So here we shall say hash include IO stream, then using the namespace standard. So then we shall have the main function. So I'm not sure if the language is already set. Syntax, yep. So we shall have a variable. Remember, we are accepting a mark, so we shall call our variable mark and we shall initialize it to 0. Now someone might ask, why do I keep initializing? I gave you that assignment somewhere in some episode, but to talk about it briefly, the reason as to why we initialize is that we are limiting the compiler from giving a dummy value to this variable. So it's better we give our own known value, like a 0, instead of the compiler dropping a value into that variable, a value that we cannot explain, a value that we cannot understand. So it is advisable you declare and initialize. Okay, so here we shall have a mark. Then what else do we need? Definitely we shall just say out, and I'll say grading system. Okay, so we shall terminate. So we shall say out again, then we shall say enter mark, enter mark. Let's be a little bit strict, between 0 and 100. Okay, enter mark between 0 and 100. So what are we doing? We have just thought about it. You never know, someone might enter mark below 0 or someone might enter mark above 0. Yet, according to how our scale is, and in real life, why would the mark exceed 100%? So this time around we are going to say cin, and cin we are accepting a mark. So in the next bit, check the mark and give a deserving grade. You see that? So I'll say if. So my condition is if mark is greater or equal to 90. Okay, if mark is greater or equal to 90. Okay, then what is going to happen? We shall just say cout grade A plus. Okay, grade A plus. Now if it's grade A plus, then we can ask again, else if. So we shall have a condition here. It's gonna be mark greater or equal to, the other one was, then we have 90 and 85. So copy and paste is fine, then we shall put it here. So I can try to be a little bit organized. So I can copy and paste. Basing, I already have 2, so 3, 4, 5, 6. So 2, 3, 4, 5, 6. Why am I doing that? This was I already have a plus. This is A. Hope we are following. So that was 90, 85, then 75, then 65, then 55, then 45. So if we have A plus, then we have A, then this is B, this is C, D, E, then we can just say you got grade F, means that you failed. Okay, so here we can say mark greater or equal to 100, and we can even say and mark less or equal to 100. I think that works perfect. Of course, we are going to see about that. So what are we trying to do? We are trying to use sequences of an if statement. Okay, which means that if someone enters a mark, that mark is going to be tested among all conditions. So a condition that satisfies the testing, its section is executed. So as usual, then we need to take this to the compiler. Okay, so to the compiler. Okay, it is saying error E was not declared in the scope. Which line is that? It is saying line 19. Is it line 19? Line 41. this was 45. Okay, mark, and someone got 77. Definitely that is a B. Okay, because greater or equal to 75, automatically it is a B. So we run once again. Someone got 90. Okay, that is automatically an A plus. And someone got 33, 34. Greater or equal to, so you see, someone got 34 and we never catered for that. Okay, so in my explanation I said if all conditions fail, then you need to cater for that too. So here we shall say C out greater or equal to 45. This was grade. Oh, that was E. Okay, that was E, guys. We missed out that. So this should have been E, and this should have been you failed, gentlemen. Okay, so once again we run, and someone has a 34. Okay, you failed, definitely. So we were trying to look at what we call a nested if, or sequences of the if statement. Now another one, let's try to look at what we call the switch statement, the switch case. It's called the switch case, or it's called the switch statement. Okay, now the switch case chooses which part of programming code to execute based on a calculated value, okay, of a certain expression. Most often it is an integer, then sometimes it can be a character. So for that case, so in most cases, syntax, we take what we call a switch. So a switch, then here we have what we call a selector or a value. So what shall we do? We shall have a case, then we shall have a label, then each label is ended with full colons. So here we shall have statements, and for every case we shall have a break. So we shall have case, label, full colon, statements, then break. Okay, now these cases can be as many as possible, but we end with the default case, then we shall have statements, definitely we shall end with a break. So the same way we have used in the sequence of the if statements is the same way something is done with a default here. So what does it mean? It means that a number of cases can be availed to the program, and you can have as many case statements as possible, but when it is working, all cases are tested. Now if all the cases fail, then we are left with nothing apart from opting for the default case. Again, every case should have a label. So a label can either be an integer or a label can be a character, okay, but each label ends with a full colon. That's what makes it a label. Now when it comes to a selector is an expression returning a result value that can be compared Okay, a selector is an expression returning a result as a value that can be compared altogether. So for that case, it means that we can use a switch statement. Altogether, guys, we can use a switch statement. But you need to note something that is very important. Okay, one, the switch statement is a clear way to implement selection among many options. So it's a clear way to implement selection among many options. So it's like you can have a menu, like someone would go to a restaurant and they're giving you a list of items that they have in the kitchen, so you can choose. So a clear way to implement a selection among many options. You have a variety of options, then you make a choice. Okay, so it requires a selector which is calculated to a certain value. That one I've already mentioned it, so I'm saying it once again. Now the selector type could be an integer. I've told you that too. Then it can be a character, or so we can always have as many cases as possible, like I've said. But when it comes to a selector, it can either be an integer or it can be a character. Are we together, guys? Now whenever we are to have any statement under a particular label, then we need to have a break. A break says please no more execution, because we have what we need already. But there are cases whereby you have a fluent check. A fluent check means that I can have multiple labels, okay, then I can allow execution, then I can have a break at a later stage. Okay, now what if for example, this is what I mean. Example, a program to accept a number from a user that is between 1 and 10, then it tells if it's prime or not. The idea of prime numbers. Okay, I'm going to just make it a little bit basic. So coming back here, I think I'll lose this comment since it's not the program that we are going to be doing. So here I can have this changed a bit. I'll say number, so telling prime number using a switch. Okay, so enter, can say enter number between 1 and 10. I'm just modifying from what you already have here so that I don't really waste too much time. So what is gonna happen, I'm going to use, of course we shall be using the switch statement as much as possible, but here I want to show you the concept whereby I can have a variety of labels, then I can have a break at a later point. So here, of course, my selector is an integral selector, which is gonna be number. So I'll say case 1, that is a label case 2, that is a label. Sorry, I'll say case because we're handling prime numbers, so I'll say 1, then 4. The next number that I can check is 6. Then case, guys, if you don't know what prime numbers are, you can make some research about it. So we can say 10. Then here I can say out something very simple. I can say the number is not prime. Okay, you can even have a new line. Now I will have a break. You see that? I will have a break. So here I'm implementing multiple labels by using the case statement without a break after them. So in this case, first the integer value of the selector is gonna be calculated. If anyone enters a number, then it's going to be calculated. So we assume there is any number that has been entered. Of course, something has to happen. So after that, I can still say we had 1, 4, 6, 8, 10. Then we can check for a 2. We can check for a 3. We can check for a 5. Which number is remaining? We can check for a 7. Okay, so definitely someone who has already read beyond where I am right now, I'll say the number is prime. You see that? So I have another sequence of labels that definitely meet a break after a test. Then finally, remember I said we need to cater for a default, and this is gonna be, so maybe someone enters a number below 1 and above what we have suggested, that is 10. So what are we going to tell that user? It's an invalid number and not known. Okay, we assume it's an invalid number and not known. So once again, Control A, Control C, back to the compiler, Control A, Control V. So we are going to run, and our testing number is gonna be 6. Definitely, if you check here, 6 is in the range of those numbers which are not prime numbers. So it says the number ain't prime. How about if the number is 5? Based on our system, it will say the number is prime. How about if the number is 0? How about if the number is 0? Invalid number and not known to the system. Guys, we said when it comes to a switch, it means we are given, or you're giving the user quite a number of options to make a choice. Okay, quite a number of options to make a choice. So basically that is what we call a switch statement, okay, or a select case statement. Now, from what we looked at in our previous episode, I'm trying to remind you, we also talked about what we call looping statements. So right now I want to tap into that and talk about what we call loops. Wow, as usual, I advise you guys, don't relax with what you've already watched in my videos. I know the videos are really worth it, but as a program, I advise you, after picking all the knowledge from here, you have subscribed to my channel for more notifications as new episodes drop in. There is no harm in doing more research. Okay, now in this section we are going to examine loop programming constructs. Okay, sometimes you call them loop programming constructs. Okay, now it means we can have the possibility to execute a piece of code or a code snippet a given number of times or repeatedly. I explained that in the previous episodes. So a given number of specified times but repeatedly. So this is what exactly happens. The reason as to why there is a repeated execution, because we are aiming at a certain result. So for until that result is given, then the execution will not stop, so it becomes continuous. That is why it's called a loop. Okay, so basically a loop is a programming construct that allows repeated execution of a given code snippet or code, sometimes may I call them fragments. Okay, like pieces. So if there is that continuous execution, a repeated execution of a given code snippet or a code fragment, then that is what we refer to as a loop. Okay, now a loop can have an end. Okay, it can have a termination, it can have a stop or a stoppage, but if at all the loop never ends, then that loop is called an infinite loop. Okay, loops that have no end, loops that don't cease to execute. Now what we are going to do, I'll begin with what we call the while loops. Okay, now ladies and gentlemen, from where we started, we looked at the if statement, we looked at the if else, we looked at nesting an if statement, then later we have looked at having a number of sequential if else statements. Now here we are talking about loops, and we have started with what we call the while loops. Now the while loop, before I explain, I'll give you a syntax. It's while. Okay, then we shall have a condition, then we shall have what we call a loop body, then somewhere here we always have what we call an update. Basically that is the syntax. So how does it work? Only allows execution when the condition is true. Only and only allows execution when the condition is true. Okay, you can say this is done until the condition becomes false. Remember we said it is a loop, so it keeps doing it for until when the condition is false. Otherwise, when shouldn't it allow execution? That is a case whereby there and then the condition is false, so there will be no execution. So only and only when that condition is true, for as long as the condition continues to be true, then it will continuously execute. That is why it's called a loop. for until when that condition becomes false. Are we together, guys? So a question for us to understand that perfectly well, guys. I'm giving quite a number of questions. Some I'm doing, some I'm not doing, for your own practice, and trust me, we shall get there. So let's say a program that will print what? Print even numbers from 1 to a limit specified by the user. Don't forget, we are using a while what? We are using a while loop. So it means that the program has to print those numbers. Okay, the program is going to print those numbers from 1 then to a limit provided by the user. All together. So let's try out this first and we see how it will work out for us. We had an option here, so allow us have a comment. Allow us have a comment up here. So we are going to change this variable to what we call a limit, and our limit is 0. So we shall say printing numbers to you can have your own statement. Me, I'm just typing this one. Printing numbers to a stated limit. Okay, so here we shall say enter the limit value, but which numbers? We said it's even numbers. So here someone is going to enter the limit since we have the variable up there. So without forgetting, what are we doing here? We say print all the events in the range. Think about that. So what am I going to say? I'm going to say while what? While limit is less or nope. We need an initial value. That is something that we had missed out, and that initial value is 1. So we shall say int I is 1 because we are printing from 1. So here we shall say while I is less or equal to, of course we are going to see what happens, is less or equal to limit. Okay, now 1 is not an even number, but we are printing even numbers, so logically our I is going to start from 2. Now to get the next number in the sequence up to when we reach a limit, it means that number has to be added another 2. Okay, not so. So here what is going to happen, I'm going to say see out. I'll begin with a number, so I'll print I. If I print I, I'll put, let them come in commas, but again we need to update I. So what is going to happen? So it's gonna be I is assigned I plus 2. Okay, I is assigned I plus 2. So each time I comes back, added 2, added 2, added 2, added 2, and print the numbers. So let's check out what we have just done. So definitely we shall come back to our compiler, Control A, Control V, and we push to run. So enter the limit value. My limit value is 10. So definitely I expect 2, 4, 6, 8, 10. Okay, up to the limit. Now what if my limit is 11? 11 is an odd number. So because we need to check for this operator here, is it working as expected? So you see that still we shall stop on 10. So how is it controlled? It is controlled by this update statement. Once again, let's run it again. What if our limit is 15? What if our limit is 15? Definitely we stop on 14. So it's working perfectly well. What did we use? We used a while loop. Okay, we used a while loop. Okay, now to modify, no, should we modify a program that will print all odd numbers from 100 to 5? Hey, guys are going to do that for me. Print all odd numbers from 100 to 5. This time around we are beginning from the biggest to the smallest. Okay, what if we have another option here, or another question? Okay, what if we modify program 1? Let's say modify program 1 so that it computes the sum of all the numbers in that range. Okay, what if we modify the program to compute the sum of numbers in that range? Okay, now here we are. So it means that we can come back here and we can say int sum. Okay, so sum is 0. I'm modifying sum is 0. So if sum is 0, it means that each time we make an update, okay, each time we make an update, then we need to compute sum. So how are we going to compute sum? So sum is gonna be, sum is assigned sum plus the value of I. Sum is assigned the value of I. Okay, so it means that the moment the loop stops executing, then it will jump out. It will jump out, then we shall say the sum is, we shall say the sum is sum. Guys, we are together. So we have modified and we want it to compute the sum. So it means that each time it brings the value of I, each time it brings the value of I, then what is going to happen? What is going to happen? It's continuously going to be adding all together. So what does it mean? Let's make a simple modification here. So here we shall say, let's say plus. Let's use a plus. So we shall continuously be adding. Okay, Control A, Control C. We shall come back here to to our compiler and we shall try to run. So my limit value is 20, so it's gonna be wow. So 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20, the sum is 130. So guys, we are trying to understand what we call the while loop. So please endeavor to do as many questions as possible for that case. Okay, so maybe I can give you another question here. You can say write a program to check whether a given number is a prime number or not. So like I had advised you earlier, if you have no knowledge about prime numbers, or if you forgot what prime numbers are, then definitely try to make some good research and make things happen. Also beautifully, here we have a question that is asking you to write a program that checks if a given number is prime or not. All together, so try to find about that, and definitely everything will be perfect. So that is what we call a while loop. Now there is a while loop, then sometimes, like I told you, we might have a possibility that we need to terminate the loop at a certain point. So we have another control statement which is called the break. We have another control statement which is called the break. Sometimes we call it an operator, sometimes we call it a statement, but I'm saying there are moments whereby I'm using a loop and maybe at a certain point it has to be stopped because of a certain aim. Either it has already achieved what I wanted, or it encountered an issue, then I needed to terminate. So the break statement is used to prematurely exit a loop, okay, before it has completed its execution in the expected way, or in the expected normal way. Okay, now when can we apply such a scenario? Sorry about that. When can we apply such a scenario? Assume I require that you assume I'm thinking assume I require you to write a program that will compute the factorial of any given number. Guys, I know some of you hate math, but definitely there is no way you can do programming if at least you don't even have the basic math. But of course right now I'm bringing in concepts, having an idea that you already know something about, like factorials, like quite a number of basic concepts that I've talked about. So let's wait for the next episode so that we continue talking about the break. I sign out.